Okay, let's dive in. Today, we're unpacking something really fascinating, the whole world of slithering. Think snakes, slugs, anything moving without limbs. It's a deep dive into their locomotion mechanics. And honestly, it's a masterclass in biomimetics, especially how they handle friction. Our mission here is to get how these creatures turn simple, wiggling, side-to-side movement, scientists call it oscillatory motion, into just pure forward movement. Sustained thrust. It's so elegant, engineers actually call it a mechanical rectifier. It literally rectifies that oscillation into straight line travel. Really efficient. And speaking of efficiency, this deep dive is brought to you by our partners at embersilk.com.
Right. And to really get that forward thrust, you kind of have to look past the visible wiggling. The secret isn't just the motion, it's down on the ground. It's friction. Specifically, it relies on something called frictional anisotropy.
Okay, frictional anisotropy. Sounds a bit technical. Is that basically just saying the friction is different if you measure it sideways versus forwards?
Exactly that, precisely. If the friction was the same all around isotropic, they wouldn't be able to move. There was this brilliant experiment, maybe a little mean to the snake, where they put it inside a fabric sleeve, kind of an isotropic jacket.
Okay.
This sleeve made the friction equal in all directions. It canceled out the scale's directional grip. And when the snake tried to do its wave motion...
Let me guess, it just wiggled in place.
You got it.
Yeah.
Slithered right there on the spot. Zero forward movement, which proves, that directional friction from the scales is absolutely essential. They need the sideways drag. That's the force pushing against the sides of the body wave. Normal to the direction it wants to go, that needs to be much higher than the drag-resisting forward motion of the tangential force.
Ah, I see. So they grip sideways to push off, but glide forwards easily.
Exactly. It lets them push off the environment with that body wave while sliding forward with minimal resistance.
That's genuinely ingenious, using friction so dynamically, not just as like a problem to reduce. So how does this jump from biology to, say, engine design? Pistons and surfaces.
Well, that's where tribology comes, in the whole science of friction, wear, and lubrication. And the connection's huge. Think about this. In a typical car engine, something like 15% of the fuel energy is just lost.
15% just fighting friction.
Primarily between the piston and the cylinder wall. Just wasted heat.
Wow. Okay, so if nature solved low friction gliding with scales, surely we can copy that.
That's precisely the idea. Engineers are seriously looking at what they call deterministic surfaces. These aren't just randomly smooth. They've carefully designed predetermined topographies, microscopic textures.
To control friction, not just minimize it.
Right. And reptile skin, with its incredibly optimized directional friction to the material level, is one of the top models. It's a key biomimetic analog.
So we're literally studying the texture of snake skin to rethink the inside surfaces of our engines. That's biomimetics driving real engineering leaps.
It absolutely is. It's applying these biological solutions to overcome current roadblocks in material science and system design. It could lead to major advances.
Slithering, then, is this beautiful example of natural engineering optimizing movement through really sophisticated friction management.
It really is. It shows how directional friction is a pathway to efficiency, and it's guiding how we think about designing advanced surfaces that might need less lubrication or just last longer.
Such a clean solution from nature for big industrial problems. Okay, here's a final thought for you, the listener, to chew on. True wheels, axles in rotation, they never really evolved in complex animals because of certain biological limits. But if nature perfected efficient movement without the wheel by optimizing friction instead, what other human technologies, things we think are obvious or essential, might nature offer a completely different, maybe simpler or more elegant solution for, just by mastering friction?